Hey guys, Mrs. Traber here. Today we're going to talk area of composite shapes. And I want to mention before we get started, we have a guest here. This is my daughter Madeline, and she's going to join us today. That's what you get when you have a teacher who's also a twin mom with infants. Anyways, though, let's start. We're going to talk area today. So learning target is to be able to find the area of a triangle, as well as other shapes that are built from triangles and rectangles and parallelograms. You'll know you're successful when you can find the area of a triangle confidently and use different methods to get areas of composite shapes. We're going to look at our assignment from yesterday, take notes on area of composite shapes, and then move on to our assignment. So first things first, check out your answers from yesterday's assignment. I've got 3 slides of that. Here's the first 2, the next 2, 3, I should say, and the last 2. If you have any questions, as always, come see me on Zoom. Let's jump in. Area of a parallelogram. So notice I have 2 shapes on the board, and one of them is a rectangle and one's a parallelogram. Well, technically, rectangles are also parallelograms, since the definition of a parallelogram is that you have 2 parallel sides, and a rectangle meets that. So we already know the area of a rectangle. It's base times height. So if we know that that's the area of a rectangle, it's the same for a parallelogram. We just have to recognize that the height needs to be specific. That's something we'll notice. The height can't be this line. Because think about it, you don't measure height in an angle like that. If I was going to ask you how tall you were, you wouldn't put the, whatever it is, I guess, tape measure from your head down to the floor at an angle. You'd go right from the floor up at a right angle to the floor. So this part is not our height. We just have to be careful of that. Our height should always be at a perpendicular to the base. So if this is the base, the height is here at a perpendicular. That's how you'll see it, or sometimes you'll see it written off to the side like this as well. But area of a parallelogram, whether it's a rectangle or if it's slanted like a regular parallelogram, this area equals base times height. Let's look at half of a parallelogram. So literally I'm going to cut these in half, and notice that they make 2 triangles. Well, if I know the area of the whole thing, if I cut it in half, it should be half that. So this guy is area equals 1/2 base times height, and so is this one. 2 halves make a whole. The same goes for this one and this one. So my point is, if you know the area of a parallelogram, a triangle is just half that. So now we have the area of a triangle formula, 1/2 base times height. So on a triangle like this, where you have a right angle, you can see the base and the height, pretty straightforward, plug it in. On a triangle like this, we have to first recognize what the base and height is. Now, if we are given this distance as the base, then the height must be here, perpendicular to it. However, sometimes it's not set up completely correctly, and sometimes instead of giving the base there, we could have had the base here. I'll put the base here. If this were the base, think about it sitting on that side, its height would now be here at that right angle. So notice where the triangle is sitting, and depending on that, you need to find the height. Let's try some. You've got 3 to try. On each one, you're using 1/2 base height. Before you get started, let's notice the first one together. They're giving you more information than you need. Recognize where the base and the height are. The base is perpendicular to the height. So if you find a perpendicular pair, one is the base and one is the height. So we need the 3 and the 14. I don't need the 5 at all on this one. So 1/2 times 14 times 3. Simplify this out and add some units. Try the next 2 as well. I'm giving students in class 4 minutes. Keep it around that amount of time and then come back to see answers. All right, here's answers to those first 3. We talked about the first one together. The second one I would have set up like this. 1/2 times the base in this case is here, 5.9, because it's perpendicular to the height at 6.8. I don't need the 8 or the 7. So 1/2 times base times height. The next one, 1/2 times base times height. The height and the base are perpendicular, so I notice the perpendicular line here. There's the height, and it sits on this distance of 6. So there's my base. I don't need the 2, I don't need the 9. 1/2 times 5 times 9. All right, moving forward, let's look at composite shapes. So there's a couple methods of finding composite areas. What I mean by that is, say I have this trapezoid that's in blue, and I cut out this circle. Composite shapes come in many shapes and forms, I should say, but one method of finding them is to find the area of the big shape, the trapezoid, and then to simply cut out the shape that was taken out of the middle or somewhere. So this would be one method, is I would find the area of the trapezoid and subtract the area of the circle. So find the area of the larger shape, then subtract the part that was removed, so to speak. Another method is if you had a shape where you could split it into manageable shapes, you can find the area of separately and then add together. So in this case, notice I could split it into a triangle where I have 1/2 base height here, and a rectangle where I have base times height here. And then at the end, I would add those together to get the total area. That's another method, and that's usually what students use. The removing method is something that only some notice right off the bat. Let's try some. You've got 6 to try. Try either method. Like, for example, I'm thinking on part B, I would definitely use the removal method. I'm thinking I would do 12 times 24 as the whole big gray box, and then take out this 4x8 box. Other ones, I might do some cutting out. Like this one, maybe you could do a cutout. You could think about the whole rectangle and then cut out this piece. Try these out. The students in class have 8 minutes. Give yourself about that much time, then we'll come back with answers. All right, let's check out answers. Here they are for all 6, and let's talk about them each. I think the ones that you're going to have questions on, if I could take a guess, would be C. So let's look at this one. I want to do base times height. Oops, that's height. Let's try again. Height. So here's height and here's base. And when I multiply these, this might be a skill you remember, maybe not. Let's do it off to the side. A lot of times you see this as a box method. And I hope that this isn't too small for you to see, but make a box and put your 2 binomials in. So 2x and 3 and x and 4. And then you can multiply the ones that are in the column and row together. So 2x times x is 2x squared. 2x times 4 is 8x. 3 times x is 3x. And 3 times 4 is 12. Now, you can combine like terms. Notice I have diagonally an 8 and a 3 to make an 11x. And then on the outsides, I've got a 2x squared and a 12. That's my area that they've got in here. They just have a unit squared on it. Another one I think you might have a question on is part D. Now, you could split this in many ways. Notice the markings, though. That's super important. So these ones that are marked congruent with the 1 tick mark, they came from a whole distance of 27. So if I split 27 into 3 pieces, I know that these are each 9s. Similarly, these double marks, there's 3 of them, and it comes from an 18. So I know that each of these must have been 6. Now, if you know that, you can probably cut this into pieces. And you could do that several ways. Maybe you cut it here, or maybe you cut it horizontally. If I did the horizontal cut, I've got a 9 by 6. This piece would be 9 times 6 is 54. That's supposed to be a 5, not a 6. 5. This piece was 9 by, how tall is it? Let's see, 18 plus, where's my net, plus 6 plus 6, so 9 by 12. That'd be a 108. And my last piece was 9 by 18. 9 times 10 is 90. 9 times 8 is 72. 90 plus 72, whatever that is. So if I added up all of these numbers that I've circled, then we will get 324. My next one, 1/2 base height, not too bad. And my last one, 1/2 base height again. I would have probably done the base as 14 and the height is 5, but you could have also split it into 2 shapes. Moving forward, you're ready for your homework. Let's look at section 222 so you can see what questions are on it. So here is 222. And the first question in review preview is 4 problems of multiplying binomials. Now, we actually just did one of these with that area problem, but if you need some help on these because you've only just seen one review and you haven't seen it in a year, it says to go back and look at the math notes box. Now, right above it are the math notes. And there's a couple examples where you can see it as the box method I showed you, or the FOIL method, which I didn't show you in this video, but we'll review in class as well. Try those ones out. If you need help, use the homework help hint. There's the area of a triangle, some angle relationships, as well as angle sum theorem with the triangles, a Venn diagram with shape recognition, and this pancake problem that's talking about probability. That's it for today, guys. I hope you had a good lesson, and I will see you next time.